Alright, so uh, let's start solving this question. So this question was my first introduction with monotonic stack, the stack which keeps or maintains an order or something. Yeah, so this was like my one of the first introductions with this topic, and yeah, let's see how it goes. I mean, I did this question and I realized that this question is having two approaches. The first approach is the brute force one, wherein the time complexity is going to be O of n square, and then the next approach is the optimized one using stack. And I guess the time complexity for that is we're using a stack and we're using a for loop. Yeah, I don't know, like 2n or something. Yeah, let's see. I'm not sure about the time complexity of it. So first of all, let's try to implement the brute force approach. So what we have to do in this question is giving nums1, nums2. What has to be done is that all the elements of nums1, we need to tell that, alright, in nums1 we have 4. So, what's the greater next greater element for 4 via nums2? From nums2 we have to tell for these elements. So like I have to tell that, alright, for 4 what is the next greater element, for 1 what is it, for 2 what is it, from how do we know for 1 what is it, from this array nums2. So that is the basic approach for this question. If we don't find any next greater element, we return -1. If we do find a next greater element, we just return that element. So yeah, the thing is that we don't want to modify the given array. So the thing is we'll need to store the element and its next greater element using a hash map. So that is something that has to be done. So let's start by creating a hash map. So I'll say hash map that's gonna take both integer map equals new hash map, right? So when I have this, now my basic thought process should be that, alright, I'll be storing the elements in the order that I want. Yeah, no worries on that. What I have to do next is that I have to figure out that, alright, I'm storing the elements in the hash map. How do I get to that point? So basically I'll be using this array only. That's a basic 2 for loop kind of approach, wherein I say int I that starts from 0 goes till nums2 dot length. Let's do one thing. I can't be writing these lengths again and again. Okay, I plus plus. So I'm saying for int I that is at 0, I'll be going till the end. For this array, I'll be going till the end, and what I'll be doing is I'll be having another for loop that is gonna be int j, that is gonna be from I plus 1, y plus 1, because I have to get like what's the next greater element. So I'll be like, oh, alright, if my I is at 1, my j has to be at 3. So yeah, for 1, if I don't get 3, I'll be going to 4. If I don't get 4, I'll be going to 2. Yeah, so that has to be the basic approach. I say j less than n j plus plus. Okay, now what do I have to do? I'll be like, okay, if you find, if you find whatever the next greater element is, yeah, if you find that, if uh, nums if nums 2 I or nums 2 j, like if my next element is greater than nums 2 I, if my nums 2 j is greater than nums 2 I, then yeah, that's what I needed. If that's the case, then cool, then it's alright. I guess that's what I have to fulfill. And then if I can't find that, I'll be having -1, because see, the thing is that if my next element for this one, if my next element is 3, then this case has to get executed. But here if it would have been 0 or 1, less than or equal to, I would have said it's gonna be it's not gonna work. Yeah, it's not gonna work. Check the next one. So and for this, it's like, it's the last element, nothing ahead of it. It has to be -1 for it to minus, yeah. So okay, now the main thinking has to be that the moment I find it, I'll store it. Yeah, because the thing is that what if I can't be dealing with, like, if this is the case, then cool, it works, else it will be -1. I can't do that, because for 1, if it would have been 0 here, 0 here, this 2 would have been the next iterator element for 1. So I need to traverse completely. So what I'll do is, this is what I think has to be done is, let's assume int x -1. Cool, I'll assume int x -1. I'll say x equals to nums 2 j. Cool, I'm gonna be like, alright, for my I, my j is greater, so let's store that in x. Yeah, so it will keep storing. Yeah, it will keep storing the greater element, and if not greater, then it won't be storing anything. It won't be executed then. And yeah, then I'll come out of my for loop with the x that is the greater one. Cool, I'll be like, okay, for loop's done, let's get out of it. And then I'm gonna be like, now I'm gonna use map dot put. I'll put, first of all, the what do I have to put? I'll be putting num 2 j, no, I, yeah, then I'll be putting x. I guess it makes sense. I'm saying for my 1, my greater element, next greater element is x, that is 2. That's my x. Yeah, cool. I guess it works. And the moment for loop ends, I am gonna, because they require integer, so I'm gonna be like int result equals to new int nums 1 dot length. Yeah, I'm gonna have a for loop which is gonna be like int I equals 0, I less than nums 1 dot length I plus plus. Cool. I'm gonna say map dot get. What do I have to get from map? I have to get that key, that key is my nums2i. I'll get nums1i, yeah. So nums1i for 4, it will be having an input. How do I put that into the array? I got this. Okay. Yeah. Cool. Wrong answer. 4 to 4. Alright, I guess understand what's happening. I guess. I guess the thing is that my x that is declared globally, what's happening is that x becomes, for 1 it becomes yeah, I'll stop it. The moment I find it, I'll stop it. I come out of the loop, I'll enter it. The thing is, for this, x becomes 3, 3x becomes 4, right? So four, 3, 4. Alright. The thing is, x is getting modified, right? X is getting modified. Before it's returning 4. For 1 it's returning 3 because I'm breaking it, and for 2 it's returning 4. I guess due to the global declaration it's happening. Yeah. Because the thing was then that initially for every element we have to assume that it's -1 so that we can change it. Before we can't assume value of its next greater element something. We have to assume -1 because that is going to be the end case if we don't find a value. So for 4 that is going to be the case, that for 1 it also has to be the case. We can't go like, alright, for 1 it was 3. Now for 3 we say x is now 4, and so for 4, if we don't find it, we input 4 only, because x was 4, we were inputting x. We can't do that. If the if condition never ran, so it just puts for 4 it puts 4, because for 3 it was 4, so it just takes that x. We don't need that. We need it to be authentic, I would say, for every case, right? Cool. Now what we can do is we can try the optimal solution, like the optimal approach, that is using a stack. And yeah, how do we do that? How do we implement the optimal approach for this question? So keeping it like pretty to the point, what we need to do is we need to be like alright, the optimal approach is gonna be like start from the last of nums2. If you find the stack to be empty, find the stack to be empty, what you have to do is, suppose I start from the last of nums2, I enter 2, stack was empty, and there was nothing in it, so I push the element. I see 4, so is the stack empty? No. What do? I say, alright, stack isn't empty. Is not 4 less than 2? No. I mean, well, if we're talking about 4, I'm gonna say is like 2 greater than 4? No, because if that would have been the case, then the 2 would have been the next iterative element to 4, but 2 is not greater than 4, so I'm gonna be like, alright, my 2 is not greater than 4, I don't need that. Cool, I don't need that, because if before 2 I have a 4, that means that any element on the left hand side of 2, excluding 4, which is also going to be on the left hand side of 4, will be having 4 as its next iterative element, not 2. So I don't need 2 then. Problem solved. So I'll be like, alright, input 2, stack is empty, push 2, then do one thing. See for 4, the stack empty? No. Is the element or there, like greater than 4? That's gonna be a no. So we just remove it. We don't need that. We push 4. Then we go for 3. We see if the next iterative element is greater than if the element present in the stack is greater than 3. We say yes, 4 is greater than 3. So in the map we put that value, that for this 3 we have our next iterative element, and that's how we can do for everything. So again, we'll be creating a map. Wait, let me take a few things from here. Yeah. Cool. Yeah. Now let's create a stack. Yeah. So for int I n minus 1, it starts from the last, I less than n, I minus minus. Cool. Now we're gonna say y till the point is like empty, false. It's not empty. Stack is not empty, and see, the thing is, you have to take care of, like, if stack is not empty, if something is in there, and if the element is less than what's there. So st and st dot p, the top element of the stack, is less than equal to nums 2 I. Yeah, if that's the case, then st dot pop, we don't need that. If that's less, we don't need that. Yeah, I guess that's fine. Yeah, and now we'll talk about if st is if it's empty, no, if it is empty, wait, I have a syntax issue. Yeah, I was wondering why it's not yellow. So if it's empty, then its stack is empty. Wait, what cases do we have to cover? Empty and less than, no, I mean not empty and less than, yeah, pop. If it's empty, we'll have to push. Wait, if it's empty is false, you know, the stack is empty is false if it's not empty. But what can be the case then? The element is greater, the top element is greater. Yeah. So I mean, can I just explicitly mention it here? Why not? st dot e is greater than nums 2 I. Yeah. If it's greater than nums 2 I, then what we have to do is that st dot is empty is false, it's greater than nums 2 I, then I'm gonna be like, alright, it works well. I'm gonna be like, alright, it works well, you know, purpose fulfilled. Wait a second. So I'm gonna be like, if st is empty and if it's not empty, but the top element is greater than nums 2I, you know, the input I'm providing it, then what you have to do is you have to so the thing is that if the stack is going to be empty, I'll still have to push. So if here also I push, if here also I push, alright, we can do one thing. I'm going to be like map dot put nums to I. For that I'm going to be st dot p, the topmost, and I'm going to come out of it. Alright, I came out of it. If the condition is done, I'm going to be like st dot push. What path push? I have to push nums to I. I'll have to push nums to I into it. I guess that works, you know. Yeah. and guess it works. Let's see. Again, cursor equals new and what then? Nums one dot length for in I to be 0 I less than nums 1 dot length. I'll be like I plus plus I is gonna be map dot get nums 1I return this. Yep. -1 what? Wait, what? -1? Index. I guess I haven't considered the case where -1 is doing something. Yeah. See, the thing is, if it's not empty element value more than the initial ones present, remove them. If the stack is not empty and the value is less than the initial ones, put them. Else what you have to do is push those elements say else like push them map dot put num to I comma -1. How? Why is this error? Who is letting them go till -1? Oh, my bad. So sorry. Oh, 4, 3. Why is this happening with this? For 2 it has to be 4. No, for 2 it has to be 3. It's getting 4. I'm stopping, how about this? Oh, my bad. Oh, I hate this. Oh, good work. I'm not sure if it's gonna. Alright, went all the way. Nice. Nice. Alright. So that was the basic thing. It's like you put the element and then, yeah, you have to push at the end because if you break it right here, it won't be executing this. If it was in here, because else it is not gonna get executed. If it's gonna get executed, and like if it gets executed, it's gonna break. It's gonna stop. So it's gonna get out of the while loop, not the while but the for loop. Because in the for loop you find a break, you get out of the for loop. We don't need that. All right, fine. Yeah, that's it for the question. Both the approaches discussed. So yeah.